Hello my dear viewers, welcome to Simplified Civil and Geotechnical Engineering channel. I am Akshay Jaiswal. In this video, we are going to discuss what is Network Survey Vehicle, why it is conducted and what data is collected by NSV. We are also going to discuss components of NSV, cost of conducting NSV, MORTH guidelines and tests to be carried out as per MORTH, also rutting depth and effects of rutting on roads. So let's start today's discussion. Network Survey Vehicle. The survey vehicle is used for automatic collection of road inventory and pavement condition related data required for road asset management, pavement maintenance management system and road safety audit related studies. And the survey is carried out by using Network Survey Vehicle. The Network Survey Vehicle is based on the latest survey techniques utilizing laser system, LiDAR system, global positioning system and high definition video image processing tools. NSV has cameras to check the things like lane markings, median width, width of drains, and it also has 360-degree camera to measure the road width, depth of works, the roughness of the road, and it also checks signages according to our specification, and it also geotags the assets. In short, these vehicles create a virtual 3D map of the newly constructed highway, which is then checked over remotely to make sure the construction has followed the specifications before giving it the completion certificate. National Highway Authority of India has decided to deploy Network Survey Vehicle to enhance quality of national highways. Carrying out road condition survey by using NSV on the national highways has been made mandatory at the time of certifying completion of the project and every 6 months thereafter. The network survey plays very important role in developing road infrastructure because Ministry of Road Transport and Highways has made this survey compulsory since November 2019 before issuing completion certificate. This step is taken to develop quality road infrastructure and ensure longevity of road corridors. As per MORTH, all projects involving development of 2, 4, 6 and 8 lanes and strengthening will have to be surveyed with Network Survey Vehicle. The NSV, which uses the latest survey techniques such as laser, global positioning system and video image processing tools, will have to be deployed before start of the work and thereafter at the regular intervals as provided in the contract for each lane of the pavement. As per MORTH, the NSV inventory data should include measurement of the pavement surface roughness, road geometrics such as gradient, horizontal curvature and cross slope, rut depth using spread lasers, mean profile depth and the GPS coordinates longitude, latitude and altitude. Cost of conducting network survey, it varies from 1700 to 2500 per lane per kilometer and it also includes mobilization and demobilization of equipment and machinery charges. It is per visit 55,000 to 90,000 depending upon travelling distance. Cost of NSV depends upon several factors such as number of repetitions, location of site, length of site, number of lanes, number of parameters to be collected and nature of data analysis. Now we will discuss how the cost of NSV is decided. Here we have two projects whose design changes are available. These are national highways with 2 lanes and paved shoulder configuration. Now let's go to table where we will find cost calculation of NSV. For project 1, design chainage is available, and from this design chainage we can find out kilometers. First project length is 100.5 kilometer. For second project, chainage is also available. From this chainage we can calculate kilometers, and second project length is 40.067 kilometer. As it is given that these projects are of two lanes with paved shoulder, we will multiply the kilometers with 2. For project 1, 100.5 into 2, it will be 201 kilometer. Then for project 2, 40.067 into 2, it will be 80.134 kilometer. Now total project length will be 281.134 kilometer. The current rate of network survey vehicle is 1700 rupees per lane per kilometer. We will multiply this rate with total length of project. Then we will get the final cost of NSV, that is 1700 per lane per kilometer into 281.134 kilometer. We will get 4,77,927 rupees. This will be the cost of NSV. Why NSV is conducted? It is conducted for safety testing of roadside furniture and road assets like bridges, signs, lighting and embankments. It is also useful for airport runway maintenance. NSV is also useful for contractors' work quality control assessment, video imaging for roadside furniture and road assets. NSV is used to process the data collected through a moving vehicle. NSV helps for maintenance to find out roughness index, wearing quality index, which is calculated in the lab. These studies specify the impact of road geometrics and roughness on the components of operating costs such as fuel, tires, spare parts, depreciation, travel time and vehicle speed. Also, irregularities in the pavement surface that adversely affect the ride quality of a vehicle. NSV is useful to predict the riding comfort and skid resistance of the pavement. The NSV vehicles are used for collecting the following information at highway: longitudinal profiling or assessment of pavement condition index, elevates the traffic conditions. Next one, longitudinal road surface profiling to check alignment, transverse profiling, pavement texture in terms of mean profile depth, road geometry data such as cross slope, gradient, curvature. It can be determined by using NSV. NSV is also helpful for assessing GPS coordinates x, y, z, that is longitude, latitude and altitude of a particular road section, pavement surface distress and roughness condition index, rut depth profiling, video imaging for pavement surface distress. These are checked by NSV. Next one, digital profile is generated and rut depth is also recorded by NSV. NSV is useful for finding roughness, rutting, geometric data, road condition data as images and accurate distance measurement. Now we will see components of NSV. First one is laser crack measurement system. Second one is laser and transverse profilometer. Third, two-line lasers for rutting profile. Fourth, high resolution distance measuring instrument, which is known as HRDMI. Next one is data acquisition module, that is computers and storage for live processing. Next one is video logging cameras on front side, 360-degree camera, 3D camera and stereo camera and also thermal camera. Now we will see components of network survey vehicle in detail with their use. Network survey vehicle has rocket grade inertial measurement unit. Our next component is distance measuring instrument. The system has a built-in distance measuring instrument attached on rear wheel. It has less than 1 mm accuracy. It gives highly accurate vehicle positioning. The network survey vehicle has optical cameras mounted in stereo pairs viewing front, left and right are used to capture 2D pictures, and they can detect objects and 3D profile of road. NSV has a front camera to optical and to infrared downward pavement facing cameras. Network survey vehicle has two sets of line lasers with 3D cameras mounted behind the rear wheels projecting to rear of vehicle, and point lasers in the wheel path projecting down. They are also called LCMS, that is laser crack management system. Network survey vehicle has several computer systems to observe and record the live data during the survey. Network survey vehicle has data acquisition module, computers, mass storage device and user interface system for live data processing. Network survey vehicle has laser profilometer, utilizes a class 1 laser profiler and accelerometers to collect roughness, longitudinal profile, macro texture and detect material degradation. It has transverse profile of the pavement surface which is generated based on the actual rut depth. Rutting profile of the pavement surface is generated using 2 line laser and 2 thermal cameras, detecting overall rut profile and the maximum depth. Cross profile straight edge is used for quality control checks of the transverse profile. NSV provides 3D profile of the road which are provided by stereo pair cameras. The GPS vision system consists of a high-grade differential global positioning system, that is DGPS. GPS vision system has desktop-based software for extracting distress and road right-of-way. Pavement right-of-way image logs are captured which are geometrically correct to quickly locate and measure any roadway feature and extract that data for further plotting on maps. Cameras are used to capture features of road. NSV has a central data logger unit integrated with inertial navigation system. Road geometry measurement is done using a built-in high-resolution inertial navigation system to calculate the radius of curvature and crossfall. Inventory and rating for pavement condition and right-of-way asset data are done using manual visual input through the keyboard with availability of keys is programmable as per user needs. The data acquisition software has a data viewing feature to plan the survey and monitor the cameras and lasers during the survey. Now we will see test required as per MORTH circular. First one test is riding quality test. Riding quality of each lane of the carriageway shall be checked with the help of a calibrated bump indicator. Second test is road roughness test. This test is carried out as per IRC SP16 using vehicle mounted bump indicator. The maximum permissible roughness for this test shall be 2200 millimeters for each kilometer. Third test is skid resistance test of textured rigid pavement. It is carried out as per IRC 35. Fourth test is falling weight deflectometer test, which is carried out as per IRC 117/2015 for PQC road. Fifth test is dowel bar scanning test. It is carried out as per IRC 15/2017. Last one test is retroreflectivity of road marking by using retroreflectometer as per IRC 35. Roughness Index test is conducted as per IRC SP 16/2019. Our next point is roughness. Roughness index test, which are useful to determine the suitability of a surface for a particular purpose, to find out smoothness of the pavement, to provide the comfort and its safety to the road user. Our next point is International Roughness Index, which is known as IRI. It is the roughness index most commonly obtained from measured longitudinal road profiles. It is calculated using a car vehicle model whose response is accumulated to give a roughness index with units of slope, that is meter per kilometer. The International Roughness Index is a mathematical property of a two-dimensional road profile. It can be calculated from profiles obtained by measurement methods such as level surveying equipment to high-speed inertial profiling system. A rut is a depression or groove worn into a road or path by the travel of wheels. Ruts can be formed by wear, or they can form through the deformation of asphalt, concrete, pavement or subbase material. In modern roads, the main cause is heavily loaded trucks. These heavy loaded trucks imprint their tire impressions on roads over the time, causing ruts on the road surface. Typically, rutting is reported in terms of rut depth, and rutting is measured at highway speeds with laser or profilograph. Now we will see effects of ruts. Ruts prevents rainwater from flowing through the side of the road into ditches or gutters. Ruts in gravel roads can be removed by grading the road surface. Ruts in asphalt pavement can be filled with asphalt, then overlaid with another layer of asphalt. Now we will see what are causes of rutting in roads. Rutting can be caused by lack of compaction, insufficient pavement thickness, and weak asphalt mixtures. Our next point is advantages of NSV. First one is proactive assessment of structural or underlying damage to road or pavements. Second one is high degree of precision in location and measurement of road condition issues. Third one is it gives a push to good maintenance policies for roads and highways with cadastral survey. Cadastral survey means survey of establishing property boundary. Next one is non-destructive assessment enables smooth flow of traffic without any jam. And last one is the road safety equipment facilities, all around road safety audit. Laser light captures road profile which are attached at front. It covers nearly 4 to 5 meter. Laser profilometry is a non-contact, non-destructive testing technique used to scan and map the surface of an object, and laser profilometry is often used as a follow-up procedure to inline inspection to help validate any material degradation and road profile. The scope of the work is to prepare a report by analyzing the data collected through roughness of vehicle. Now we are going to discuss pavement roughness. It is an expression of irregularities in the pavement surface that adversely affect the ride quality of a vehicle. It is also known as pavement unevenness. NSV is useful to predict the riding comfort and skid resistance of the pavement. The studies specify the impact of road geometrics and roughness on the components of operating cost such as fuel, tires, spare parts, depreciation, and travel time with vehicle speed. There are two types of network survey vehicle. First one is which are fitted with LiDAR system, and second one is by using software which can create 3D mapping and do image recognition via normal cameras. NSV data of the pavement has to be collected for each lane with the speed of vehicle varying from 10 km per hour to 70 km per hour. Ideal vehicle speed maintained is usually 40 to 50 km per hour on highways during each lane of NSV data capture. Each run of NSV with pavement camera can capture about 3.5 meter width of highway. Multiple runs are usually required for capturing more than one lanes on highways and expressways as per the project requirements. In one day, about 100 km length of NSV data can be easily collected by NSV with pavement camera in a single run. The raw NSV data collected on site is so dense that it has to be downloaded into external hard disk and transported to the head office for further data processing and pavement analysis. The data collected is about 100 GB for 100 km length. Now we will see MORTH guidelines in detail. MORTH has given policy guidelines on surveying with network survey vehicle for all the projects involving development of 2468 lane. Ministry has been mandated to develop quality road infrastructure. The prevailing contract document of authority engineer and independent engineer provides for conducting road survey with NSV. As per contract, NSV has to be conducted on completion of the work and thereafter at the interval specified in the contract. The matter has been considered in the ministry and it is felt necessary to record the condition of highway prior to the commencement of the work in order to have a documentary evidence for status and condition and quality of road. On completion of the project, this work may be invariably done and recorded before issuing completion certificate. The minimum parameter which has to be recorded during the survey with NSV in each lane includes following data. First one is inventory of the road, that is GPS coordinates, pavement type, pavement width, terrain land use, shoulder type and its width, drain type and width, median type and width, wayside amenities, crash barrier and signages. Second one is condition of road, roughness, rutting, distress, that is cracking, potholes, bleeding and surface failure. Therefore, it is decided that for all the projects involving development of 2468 lane, expressway and stage strengthening necessarily be surveyed with network survey vehicle before start of the work and thereafter at regular intervals as provided in the contract for each lane of pavement. The time interval for carrying out survey using NSV shall be as under: before starting of work, before issue of provisional or final completion certificate, and every 6 months after completion of work. In respect of EPC projects costing up to 300 crore, where State PWD or NHAI is acting as authority engineer in accordance with Ministry's guidelines issued wide letter number RWNH 34048/7/2013 dated 29 October 2018. The road survey with NSV shall also be conducted by executing agency as per procedure, and time interval specified above and completion certificate shall be issued only after obtaining satisfactory results complying to Ministry's or IRC specifications and manual. The data collected through NSV survey shall be uploaded on NHAI portal, where it will be analyzed by Road Asset Management Cell to assess the condition and roughness of the road for maintenance.
Hope you liked the information given in this video. If you are watching my channel for first time, then click on subscribe and share with all your friends. Thanks for watching. Jai Hind, Vande Mataram.